Thank you for joining us for today's webinar, Mortar Selection Simplified, Keraflex Technology to the Rescue. We have some brief housekeeping before we start. Your phones are on mute. If you have any questions, please type them into the Q&A box in the corner of your screen, and we'll answer them at the end of today's session, time permitting, or via email after. And you can always send questions to mapeidigital@mapei.com. Now, without further delay, I'd like to introduce today's speaker, Brian Pistolka. Brian is MAPEI's business manager for tile and stone installation systems for mortars, waterproofing, crack isolation, and surface prep products. With more than 35 years experience in sales, marketing, sales management, business development, and product management, Brian brings a wealth of knowledge to the flooring industry, one that he shares with us today. Brian, the floor is yours.
Thank you, Jen. And I'd also like to thank everyone for joining us today for the Keraflex Mortar Selection Simplified webinar, where we'll talk about the Keraflex technology to the rescue. To give you an idea, just quick overview of what we'll be talking about and tying together, I'll be talking about the types of mortar on the market today, the pathway to industry mortar technologies, changes that are driving mortar technology, why the different types of mortars were developed, the industry standards affecting mortar types, large format tile requirements that affect mortars, and then we'll go into the Keraflex mortar series. To begin with, I want to talk about the types of mortar on the market today. Why so many? This is a question that I hear internally at MAPEI from everyone from operations to management, as well as from customers and contractors. Why do we have so many mortars? Let's look at the type of mortars that we do offer currently and begin and tie together why they were created, what their purpose was, before we go into the Keraflex series. But the different types of mortars on the market are the unmodified thin set mortars, those that can be used with the latex polymer additives. There's polymer-modified mortars, there's medium bed non-sag mortars, full contact mortars, lightweight mortars, glass tile mortars, large and heavy tile mortars, gauge porcelain tile mortars, and there's also specialty tile mortars that are designed for applications, say over steel or with epoxy backed or resin backed tile. And then there's also additional mortar differentiation to make it even more complicated. You have fast setting mortars, you have different price points or quality levels. So to the original question, why so many, it becomes very obvious that we do have a lot of different mortars that are offered on the marketplace today. What I want to talk about is how did we arrive at what I call mortar mania? Let's look at the industry path to how we got to where we are today, which mortars are really driven by the tile and the substrate changes, technology related, that affect the mortars that we develop. If we go back in the time machine, and in some places it's still being used, the mud set was very, very common and prevalent, where you mix sand, cement, and lime on the job site. And at that point, they even soaked tiles prior to setting in a fresh mud bed or a mud bed sprinkled with Portland. The next generation was the TCNA formulations, and they come in two versions, a 759 and the 763 base formulations, one being a wall and one being a floor. Actually, back when these products were in the marketplace, the TCNA received royalties from the manufacturers for every bag of product that was sold. The next generation that we moved to were modified epoxies. These were also TCNA-based formulations where they were a modified version of a sanded cement with an epoxy, basically designed for difficult to bond to tile or applications where you were going over plywood substrates. Then we went to additives on the job site, whether they be an SBR type basis or an acrylic basis with an existing thin set type of a mortar. Then came unmodified thin set mortars, which did not use the 759 or 763 formulations. And this is actually the point where the tile industry began to expand and grow as manufacturers were differentiating themselves from the standard TCNA 759 or 763 formulas. Then we moved into a single component polymer-modified mortars. Then we had the predecessors, which were called the medium bed mortars, which also expanded into full contact mortars, lightweight mortars, glass tile mortars, and then the thixotropic mortars that we see today on the marketplace. What I want to tie into with this is, why did this occur? You're looking at the changes were really driven from two perspectives. One being the tile that were in the marketplace. Probably not many out there, if any, remember 1920s to 1940s when mosaic tile, 3x3 or smaller tile were in fashion. You probably began looking in the 50s and 60s where tile were still 4 1/4 and 6x6. Not until the 70s or the 80s did the 8x8 become a popular size. Unfortunately, I can remember those days when the 8x8 monocultura was introduced into the marketplace, and all the oohs and ahs that came from the consumers and related to this new look in the tile industry. And believe it or not, at that point, everyone was saying that's a large tile. But then we moved into the 1990s, and we had the 12x12 craze, followed by the expansion into 16x16 and even 18x18. And at this point, the thought of the size of the tile was just tremendous. But it didn't stop at that point. In 2000s, we moved to 24x48 or even 12x24 plank tile. And then we looked at in 2010 a large format where we redefined it where a tile was large format if it had any one side greater than 15 inches. Next, we moved into the GPT panels that are as large as 5x10 feet in size. Now, that is one element of change that causes mortar manufacturers to reformulate and to make changes in their offering. The other is the substrates that are driving the changes. Now, typically what we find in the industry is that the market is ahead of the specification industry in reference to substrates, because substrates come into the marketplace before they have been tested, evaluated, and installation guidelines built around. But looking at the changes, and we see the impact on the tile as well as the mortars, because traditionally floors were either were mud set, they were either bonded or unbonded. And I really look that the cement board, when they came into the marketplace, really changed our industry forever, because it took a product that provided reduced labor, reduced skill set installation, making it more available from an installation perspective and cost perspective to the consumer. But that change also had a resultant change in the mortars that were used. Another change was bonding to plywood. Originally, everything was floated or mud set, bonded or unbonded, and bonding directly to plywood was a major change within our industry. Next, associated with the wood substrates were joist systems. Now, the joist systems originally were 16-inch on center, and they were 12x2s. Later, we moved into 19.2 on center systems that had an I-joist type of system, and then later that spread to 24 inches on center, and is pretty much stopped at that point, which is maximum. Now we look at concrete mix and quality, and we know from perspective of installing to concrete that concrete has changed over the years. In the last decade, fly ash and other additives have been added to concrete. Post-tension slabs have become very popular. And we also know that the slab finishes have become much finer. Maybe not flatter, but more smoothly finished. Also, we've expanded into foam backer boards, foam shower pans, and either other systems of wall boards that are on the marketplace today. Also looking at membranes. If we look back 20 some years ago, the membranes were just breaking out at that point and being used, but now it is very common for crack isolation membranes, waterproof membranes, sound reduction membranes, or uncoupling membranes. So all of these changes have an impact on what the mortar manufacturer does and creates to address keeping quality installations in lines with the tile and the setting systems. Mortars, if we look at, were developed to address the changes in the types of tile and sizes. If we look back when thin set mortars were developed, there was the 4 1/4, the hexagonal tile, the mosaics, the 6x6 bis tile, or even the quarry tile, which were 6x6, 4x8 in their size dimensions. Often set on fresh mud in those scenarios or over concrete. The standard polymer modified thin set mortars were developed when the 8x8 Monocatura or the 12x12 stone or porcelain tile become into the marketplace and were being installed on floor applications. Also, during the 90s, we looked at a push towards the repair and remodeling market, which was a very strong push, pulling tile into a market that had currently not been as available as the sheet vinyl or the VCT were more popular. The other scenario that came into play from a manufacturer's perspective is now customers wanted to install directly over that VCT, or they wanted to install over that adhesive residue. And the use of tile and exterior and submerged applications also became prevalent. Then we look at the thixotropic polymer modified mortars. They were developed to address the new standards that were created related to large and heavy tile format that were 15 inches or longer on any side of that product. And we also look at during that time, we also noticed that the walls were also being installed. Previous to that, wall applications and many times were just in shower installs or backsplashes, but now we see tile installed on the wall in many different types of applications. What I want to pull together here is an explanation of why the different types of mortars were developed, so we can get an understanding of the features of those products, where they come to play, and then lead into the Keraflex tie-in with the various mortars that we're talking about. If we looked at the unmodified thin sets and polymer additives, the polymer additives to this day still offer the most flexibility, deformability, expansion, freeze thaw, contraction, or solution in extreme conditions. There are many advancements that have been done in the single component, but the single component spray dried polymer technology is still not to the level of a liquid latex additive. The polymer modified additives were really brought about because we were looking for single component products, mortars, to simplify the liquid powder scenario. There were issues on the job site with liquid freezing. They were easy to use and creamy products. The other side was I often heard of latex on the job sites, walking off the job sites. So it was a constant problem where they were looking to provide a single component solution to this scenario. The next development of mortars were the medium bed mortars, or the non-sags. Now these predecessors were really very heavy, coarse sands, very thick type of body, very gritty. And this was when the term medium bed was in vogue, and it has since been removed from the terminology of the tile installation of the TCNA, and is now referred to as large and heavy tile. The full contact mortars came into position during the 12 by 12 era, where it provided the ability to wet out that back of that 12 by 12 and achieve the transfer and coverage without back buttering. The lightweight mortars came into existence for a couple of reasons. Number one, they used an alternate filler besides sand, which had a high recycle content, so it was on the environmentally friendly mode of development, but it also provided some very unique properties, being able to cover the same amount of material with 25 pounds that you would use with 50 pounds of a standard mortar. But it also had very unique properties with easy glide troweling, and also the consistency where it would hold on the trowel like a mastic. Looking at our progression into glass tile mortars, they were created because they provided that bright white color to complement the clear or translucent glass tile, but they also have a workability feature, a grab, but also the ability to knock the trowel ridges down easily and maintain the thickness of the mortar bed that you're looking to provide for the glass tile. The large and heavy tile mortars came out with their non-sag, non-slump properties, looking for lippage control and also being able to support those heavy tile. The gauge porcelain tile mortars were really developed as we progressed with the large panels, because the issues with large panels were that you had a limited amount of time to trowel 50 square feet on the wall, 50 square feet on the floor, and you needed the product to be open longer and workable longer. And once you placed that 5 foot by 10, you needed some adjustability or some ability to move that product into position. So you needed that slide capability. The other side is you're looking at a panel that large with mortar underneath. You're wanting a mortar that is going to set faster and develop bond strength sooner. So that was the impetus behind the development of the gauge porcelain tile. Specialty tile mortars, we recently came out with one called the GPT that is really designed for bonding these panels on the walls to remove that double troweling aspect of troweling on both the substrate as well as the panel. And then we have additional mortar differentiation, which we talk about from a point of price point consideration and the expansion of the core product to good, better, best in many times, as well as a fast setting. I just want to touch briefly when it comes to the specifications, because the specifications also have an impact upon the type of mortars that we develop, because we need to keep into consideration meeting specs, but also meeting particular specs at price points. Of particular perspective here, we're looking at 4 or 3 specs that are really prevalent today: the 118.4, the 118.11, and the 118.15. Now you'll see that over the years, ANSI has improved their differentiation of products, a lot of it driven by the ISO specifications, but we've extended into the H, which is a designation for large and heavy tile that is associated with the Robinson test panel and meeting that extra heavy rating, but also a minimum of 1/64 of an inch lippage. The T is for the non-slip, F is for fast setting, and E is for open time. There will be a future spec also that they're working on that is related to mortars associated with panel installation. The one point I would mention on ANSI is that it's a shear test. Now, all of these tests are designed to represent the forces of nature that will potentially cause failures on the job site, and in this case, it's shear. When we're talking about shear, we're talking about expansion and contraction, or plywood expanding and the tile shearing off. So that is what is measured when we talk about the ANSI specification. I say that because the ANSI is also independent from ISO. ISO does a separate measurement of bonding because it does a tensile pull. The reason it was created because the tensile pull gives more uniform, consistent results than ANSI. So it was looked at as a way to view mortar performance with a closer parameter of bond strengths in a tighter range. Now, when we look at ISO, we see that ANSI has represented many of the scenarios associated with ISO, with the fast setting or the E, but there are some that they have not incorporated into their situation, which is number one is the deformability of a product. If we think about deformability, the best way to visualize where the demand for deformability would be on a second story mall application, because we all know when we're walking on that mall, it's bouncing up and down. That's deformability. And the demands for a product related to deformability are different than the demands related to a product for shear strength. One other comment I would make on the ISO is that there's also different classifications of cement. There's a C1 and a C2. The C2 is an improved product of cement, which means it's going to have better performance in water exposure or high heat type of environments. I've often heard people say that, well, you know, our product has a higher cement content than yours. And to that, I say it's irrelevant because it's really the formulation and combining the micro ingredients, the polymers, and the cements, all in a combination that give you the performance that you're looking for. And the other side, I say, when people are saying, well, our shear numbers outperform your shear numbers. To me, you're just looking at the product from one particular vantage point. Our products are developed taking into account both ANSI and ISO qualifications, because from my perspective, we don't know when that mortar bag is going out, if it's going to be in an installation where we're looking at a tensile problem or we're looking at a shear problem. So we formulate our products to meet both specifications and to provide the products that you need and specify for the job environment that you are looking at using the products in. The other rating that I would look at that ties into how we develop our products and why so many mortars is the Robinson floor testing machine, and the ratings is residential all the way up to heavy commercial, and the need to develop products to meet the environment that it is going to be utilized in. I just wanted to touch on this from a perspective as we talk about the size of tile and the large and heavy tile. Now, tile that are shorter than 15 inches on center, there is a different allowable variation. It's a 1/4 inch in 10 feet, or no more than 1/16 inch in a 12-inch area. Now, if we're looking at large and heavy tile format, we see that changes. We see that it has a maximum allowable variation of 1/8 inch in 10 feet when you're looking at a tile larger than 15 inches, or no more than 1/16 of an inch measured in 24 inches. Now, looking at substrate related to flatness. As we saw in the previous slide, as the tile size increases, the effect of substrate irregularities are compounded on the installation. If we're looking at plywood, it's very critical that the adjacent edges not exceed 1/32 of an inch difference in height. What I want to touch here on is just what are the challenges that large format tile meet in the marketplace. Now we know that there's warpage in tile. There's a TCNA standard related to what is acceptable warpage within a tile, and it's based upon the size of that tile. The impact of the concern is from the lippage perspective. Now, other scenarios, we know that when we're dealing with bonding patterns, when we're dealing with porcelain tile with the wood appearance, these become more challenging to install where warpage becomes more obvious. Also, the grout joint width plays a component part in the challenges related to lippage. Certainly the substrate tolerance, how well that substrate was prepared, and the curvage of the installation all play together. But to me, the bottom line related to the solution is coverage. As they say in the realtor industry, location, location, location. For large format tile, I say coverage, coverage, coverage is the key to a successful installation. Just to touch base on the load and deflection goes back to what we spoke to regarding deformability. And you'll see here that a small tile, the deflection is not as critical as it is as you move up with a larger format tile or a random pattern. Now, here's the consideration related to the compound effect. If you're looking at all of these variables individually, you have one concern. But if you look at all of these variables combined together on a job site, now you see the reason for a large and heavy tile versus the mortars that are just polymer modified and do not have that H rating for large and heavy tile applications. Looking at the successful large format tile installations, the variables as we spoke are the flatness of the substrate. You also have to take into consideration mortar shrinkage. If you're looking at the standard polymer modified mortars, they have a limitation related to the thickness, whereas if you're looking at a large and heavy tile, they say mortar that you can use it up to a ½ inch embedded. I will bring one point out here where industry used to say you could build a mortar up to 3/4 of an inch. The issue with that was not related to a concern about building these large and heavy tile mortars to 3/4 of an inch. The issue was many contractors were faced with the prep work being pushed out of the bid because the architect looked and said, well, we will just specify the medium bed method so that no prep is necessary. So there was a confusion in the industry in reference to that term medium bed. Thus, it was changed to a large and heavy tile so that everyone would benefit from the fact that the prep still needs to be done and the installation needs to follow the standards and the specification. These mortars are also designed for non-sag, non-slump, and they take into effect consideration for stone warpage or heavy type tile or stone. Looking at the successful installation, again, some more points. The surface prep we talked about, we need to be 1/8 inch variance in 10 feet. We need to understand the benefits and the limitations, and to the point, coverage is critical. And moving on, what I would like to bring us to is enough on mortar history. I want to talk to you about what changes are coming. Now, history puts changes in perspective. Nothing is constant or forever, and there is change continually in the mortar industry as we detailed related to the challenges that we face. Now, industries and products change, product life cycles evolve, but maintaining a relevant company position requires change to align yourself with the market. We can all think of companies, even in our industry, that may have been leaders at one point, but did not embrace change in technology. They were either sold off or dwindled in reference to their success in the marketplace. So companies can be lost to technology change. I'm sure that many of you in your lifetime recognize products that are no longer in existence. For some of us that are a little older than others, it would be the typewriter. And there were two types of typewriter, Pica and Elite. Just like we had the DVD players with two technologies, they have disappeared. You look at things like telephones, or you look at reel-to-reels or the television predecessors. Technology changes, and one needs to stay up with it. In a mortar manufacturer, it's no different. Which brings me to the focal point of tying this presentation together to the Keraflex series of products. They're looking at simplifying the mortar selection process. We look at the Keraflex technology to the rescue. Now, when I look at what does Keraflex do for us, it allows us the consolidation of the mortar functions. If we look back on the polymer-modified mortars, they were developed to have lower viscosities. They had good wet-out transfer, and they're used frequently with membranes. The medium bed products, they were designed to be non-sag, non-slump, and support the tile and grab on the wall applications. Full contacts were designed to eliminate that back buttering, but they had limitations on the size of tile that would be able to be used with those type of products in order to achieve that level of wet out, because if you used larger trowels, then it becomes complicated in reference to sinking and sagging of a product that is that loose in the mix. The lightweight mortars with their alternate aggregate compared to sand also offered some unique properties, and one of those properties were their mixing capabilities and their smoothness. They're easy to trowel. The glass tile mortars were products that had very high bond strength, but they also allowed the ability to flat trowel or to knock those ridges down. And then the large and heavy tile mortars that came into existence focused heavily on a very heavy body product that supported non-sag and non-slump installations. Gauge porcelain tile, the purpose or function of that was really for high transfer, wet out capabilities, and adjustability. Here's where I say that we pull these things together. Where Keraflex series combines the mortar type technologies and their uses in one product line, which we'll discuss as it really fits those requirements from an application perspective, as also from a user perspective, that we detailed with the standard polymer modified mortars, the large and heavy tile mortars, the full contact, the lightweight, the glass tile, and the gauge porcelain tile mortars. So here we have one mortar technology that addresses not only the needs of today and tomorrow's tile, but it also addresses those characteristics that the other products were built based on. So it's very unique, and from my perspective, and I may be a little impartial since I'm involved in the product management side of it, I look at this as a real game changer to the industry. What I want to look at is the tangible benefits of this technology to the distributor and retailer, which there are many. Actually, I had to cut off the last 4 or 5 from this slide and to try to reduce it, as painful as it was to me, to take some of the bullets off. But I look at this product as really being an offering simplicity, consolidation, and versatility to the distributor as well as the retailer, because it offers the ability to reduce inventory, dollar investment, reduce the space with product consolidation, increase your inventory turns, reduce your product outage or back orders because you're not handling such a broad line of mortars. So you're able to turn trucks quicker with these products, as well as stock be more in stock instead of spreading it over items that may not have the turns or the usage, but maybe more specialized. Reduce the mortar complexities all across, whether you're at the counter selling or whether you're in the field selling. Create a sales opportunity, a growth opportunity. This gives the MAPEI customer the availability to take a new message to the street, a new story and an exciting story that gives them the ability to be a market leader in their particular area. And to go after business that you may have been hearing no for a long time. You now have a very solid reason to represent and to show the MAPEI products, no matter what product they're using. It also simplifies the training for employees because it gives them a finer selection of products to be knowledgeable in more depth about, instead of understanding all of the other products and the ins and outs, where with the Keraflex, the in-depth knowledge and use of this product allows them to focus on a much less broad spectrum. It also simplifies the selection for your customers. Looking at a project manager, what are his tangible benefits? Looking at it makes his job site staging easier, ensure he gets the right products on the job the first time. He can align the tile and the substrate with the installation needs, reduce his error rates, reduce the mortar complexities and variables, also simplify the training related to his men, related to mortars, improve job site efficiencies and productivity because they'll be working with the same products over and over and over again. Which will also improve installation quality when we get into the fact of the high transfer technology related to these products. What are the benefits related to the installation team? When we're looking at it reduces the mortar complexities. It's installer friendly for both the application and the performance. That's one thing I would also like to touch on in reference to when someone is looking at one particular number and saying, well, that number is lower than the product that I use. The reality of it is there are products out there that have some nice numbers that they throw up, but they're miserable to work with, whether it be the mixing, whether it be the troweling, whether it be the transfer, whether it be the open time. There are many, many considerations for a mortar. So looking at one number is really short-sighted. Because that number may be calculated based upon a water add ratio that you're not using on the job site. So to that point, always look at the product in its entirety to get the perspective of what am I really buying. Align your tile with the substrate installation needs. Looking at the consistency of product use with many variables, substrates, application, job sites. And this will improve the installation quality with the high transfer technology. Another area that we've tied into with this technology to align it with the way tile are being installed today, this product was formulated to complement those tile that are being installed using the Lippage control systems. As we find, they are very prevalent in the installer community to this day, and this product works well with that method of installation. Aligning with the adjustability, with the transfer, with the wet out capabilities, to go hand in hand, making that connection with the changes in the industry. They improve the job site efficiency and production because they're working with a fewer variety of mortars, and they're working with that less selection more frequently. So also it will simplify the installer training. Let me go into now the star of the show, which is the Keraflex line of products. What sets these apart from other products is that they're extra smooth with high transfer technology. Now, looking at where MAPEI is with the product launch, we had launched this product earlier in Canada in actually 2018. So we have a track record of success with these products. It's unusual for us to introduce first in Canada, but the Canadian market called for this type of technology prior to us moving into the USA. And quite honestly, it was a much easier process because we have so many plants in the US to produce product from that it took us longer in order to develop formulations in multiple plants. But to begin with this year, March 2020, pre-COVID, we introduced the Keraflex Super to our line. Now this year in September, we've brought the remaining 3 products into our offering and have introduced beginning on September 8th, the entire line of the Keraflex product offering, which involves a Plus, an RS, and an SG product, which we'll go into in some basic detail. How does the industry define the large and heavy tile? We've touched on any size greater than 15 inch, but for a heavy tile, it's called a tile weighing more than 5 pounds. Now, what I want to talk about is the Thixo technology. We have advertised and promoted the Thixo technology with our core line of LFT, LHT, LHT SG over the years and have been extremely successful. And many contractors have enjoyed the use of this product and have many believers in both its working properties as well as its performance. Now, the scenario with the Keraflex is it's also thixotropic in application and in determination of its definition, which I will explain, but it is at a much lower viscosity. If you looked at thixotropic mortars and you were in the lab looking at the centipoids, you would probably see that a thixotropic mortar is probably like 1.2 million centipoids, where if you look at a Keraflex type of product, it's more in the nature of 300,000. So you look at that as a very serious difference in thickness of the 2 products, and that's why we refer to it as a smooth or high transfer type of product. Now, when I talk about the Thixo mortars, the best definition of Thixo to put in perspective of what this mortar does would be ketchup, because we all know when we grab the ketchup and are looking to complement our fries that we have to shake the ketchup because it's thixotropic. So it's very heavy body. You couldn't get it out of the bottle without a serious fight if you didn't shake it, which caused a movement, which caused the viscosity to change. So that allows you to get the ketchup out of the bottle, and then when you place the bottle back on the table, it bodies back up again. So the next guy has to do the same thing to the product. Another one is quicksand. If you look at quicksand, when you're standing in quicksand, you're fine. If you start running, moving about, fighting to get out of it, you just sink further and further because you, with movement, created a different viscosity in that quicksand. Now, how does that relate to a mortar? If you look at a mortar, when you mix it up and you slake it, it becomes heavy body after you slake. Now, when you're troweling on the floor, you're breaking it down with a motion or an energy. So it becomes easier to move. But when you stop troweling, it turns back into its original state and it bodies up. so that it will keep a tile from sinking into the mortar, or it'll keep a wall tile from sliding down the wall. So that's where the Thixo terminology comes into play. What I want to look at with the Keraflex products is what are the innovations that make Keraflex products different from the other products. Realistically, the key points are its high transfer technology with a high mortar yield. It has superior mortar wetting properties. It's ideal for the lippage control systems, and it has an easy glide technology that offers extremely easy troweling, a very buttery consistency, which is going to reduce the fatigue from the installer's perspective. Also, if we look at trying to define what makes these products different, we look at it has a finer aggregate that allows a low product viscosity. So because of this aggregate that's incorporated into the formula, as well as the cements that are in there, the polymers and the micro ingredients, it has a different body consistency than other mortars on the product. And you will notice that it is very smooth and very buttery. But those features also tie into the fact that it wets out the back of the tile, or it wets out the substrate and enhances that transfer, which gets to the point of the better the coverage, the better the bond. Because if you look at mortars, they're evaluated based upon their working time, and the longer you leave a product troweled into the field, you know, the less coverage that may be transferred associated with that. Also, they're ideal for lippage control systems and for non-sag, non-slump situations. I think I'm having some technical difficulties here, but let me proceed. Let's look at other Keraflex features. The frost resistance, and it's also highly resistant to freeze thaw. That would be the Keraflex Super in the line. And then we're looking at easy mixing properties. They blend together differently than other mortars do. They're easy to trowel, require less average. They also get higher coverage rates per pound. The 44-pound does in coverage what 50 pounds of polymer-modified does, or even greater. If we're looking at the Super, this product is truly super, as I say, because it has very unique properties and it has a much higher coverage rate than do the other Keraflex products in the line. It is definitely unique in both its performance as well as its application properties, because it has an extended working time of up to 50 minutes, and it has an open time of up to 4 hours. It also meets the 118.15. Of course, it's an HTE. All the products are HTEs, but it also is an S1 for deformability and a P1 related to plywood. Looking at some of the performance features, I just touch on the most critical one is always the porcelain or mosaic bonds, where it's 425 to 550. It is a high bond, high technology product, but it's also deformability related to the S1 classification. All of the mortars except for the Facet are E in reference to having 30 minutes open time, but they also have even more when you're looking at the Super and the Plus. But the other scenario is it works with a multitude of substrates in reference to the VCT, the sheet vinyl, the cutback residue. And these are, of course, properly prepared ceramic tile, porcelain tile. And then it has some unique properties where it can be used in water immersion applications, can be used for glass tile, can be used interior, exterior. So this is where I see the consolidation of other products in the line, that this gives you the opportunity to pull in the Keraflex line of products and limit the other products. Certainly it will take time to transition, but the formulas and their applications and uses provide the opportunity. Let's look quickly at the Keraflex Plus. The Keraflex Plus is the professional grade product. All of the features that we talked about in reference to the ease of mixing, the ease of application, but it has an extended open time of 30 minutes and a pot life of 3 hours. It's a 118.4 HTE, as they all are, we discussed, and they all bond to plywood. Also, it can be used for VCT, existing ceramic and porcelain tile used with membranes. It's not designed to be used for submerged application or for those extreme exterior type of installations. Then I look at the Keraflex SG, which is a standard grade mortar. It's available in the 118.4 HTE and bonds to plywood. You'll see that the pot life is a little less than the other ones, and it is a base grade entry product, but carries the features of the wet out, the transfer, the open time, the adjustability that we've detailed with the other products. Looking at what I wanted to speak to related to, they have different mixing ratios. They're looking at different products because they are unique, and they have a different high-low and water add amount. Now with a low water add ratio, this is designed for use for a non-sag, non-slump type of application, but it also has a high water add ratio that is designed if you're looking at using with membranes and you're looking at better coverage. I will make one point because the sales team continually tells me they get so much better coverage than you report. The coverage is based upon that water add ratio for a non-sag, non-slump application. So yes, indeed, if you're going to mix at the higher water ratio, you're installing membranes or you're installing applications over membranes, and you're mixing at the high water, you're going to get probably 10% at least higher coverage than you would when you're mixing at that lower, thicker ratio. But for the point of calculating coverage, I want to use that middle figure, so that you do not anticipate that you need less material than you do on the job site. Looking at the other product that I didn't touch on is the Keraflex RS. Now this product is a fast setting version of the Keraflex with all of the application conditions that we talked about, with transfer, with wet out, with the smooth, creamy consistency, except that it's a fast setting product. You can grout in 3 to 4 hours, and you have an open time of 10 to 20 minutes and a pot life of about 30 minutes. The last point I want to talk about is the variance between these products and some of the unique properties, which we've already discussed, and I just wanted to highlight that the products like Super has a longer open time with more working time, and the Keraflex Plus is a little bit less. Their bond strength performances are less, but the substrates that they go over are also different. So those are the variables that are at play within this. So let me now go to any questions that may be out there. Jen, do we still have connection, a voice connection?
Hi, Brian. Can you hear me?
I can hear you.
You can hear me. There are a few questions. Hang on one second here. If one was to try to reduce the stocking profile of mortars to a minimum, would it be sufficient to just carry the Keraflex line and nothing else? Provocative question.
I would like to say yes to that, but being in this industry as many years as I have been, I see it as a transition. I see that when you have users that have been using products for 25 to 30 years, there will not be an immediate switch over. So I see it as a progression. where you will bring in the Keraflex line. And it depends upon your customer base as how quickly you can transition them out. But in time, yes, I see the Keraflex product line as replacing products in the line, and some products going by the wayside. In particular, I would probably look at the alter contact mortars going by the wayside. So that's how I view it, and it will be different based upon each individual business and each individual clientele. But that would be the end game and the behind the products.
Okay. Can you use the Keraflex in as thick of an application as you use Ultraflex LFT?
Yes, they are both large and heavy tile mortars with the H designation. Now, the H designation declares that you can use an embedded thickness up to 1/2 of an inch. If you look at embedded thickness, that's realistically an inch of material troweled to embed down to 1/2 of an inch. So you can use them to the same degree in reference to application.
Great. I think we have time for maybe one or two more. What are you hearing from distributor customers and contractors who have used Keraflex mortars?
What I'm hearing is all good news in regards to, I've heard many sales reps. Now we had a Keraflex tour for 9 weeks where we traveled around to our distributors, presented the products. And I've heard from sales reps and business development leaders and sales area managers that in some cases, contractors see the product and immediately put it on their truck. In other scenarios, I've heard where distributors will come and place a truckload order the day after the seminar was conducted because they fully believe once they see the product, because seeing is believing. Once you see this product, the first time I tell you that I saw this product trialed in the lab, I thought, wow, that technician better move his feet because that tile is going to land square on his foot before he can get it out of the way. But unbelievably, it held at such a low viscosity with great working features. So we've been, as long as I've been in the industry, I have never heard so much positive feedback and input related to a product launch in my life.
That's great. Can you compare Keraflex line to the Ultraflex line?
To the Ultraflex line,
Yeah.
if I look at comparing it to the Ultraflex line, I would look at Ultraflex 1 as being equivalent to Keraflex SG. I would look at Ultraflex 2 being equivalent to Keraflex Plus. I would look at Ultraflex 3 being equivalent to the Keraflex Super. Now, when I say equivalent, I'm talking about the bond strength. No way, shape, or form do I look at those two technologies as equivalent because I look at what you're getting with a product like Keraflex. You're getting a product that can be used with large and heavy tile, non-sag, non-slump, super creamy consistency. You're looking at wet out transfer. You're looking at being able to be used with edge leveling technology. So when I say that, I'm saying it from a point of pure performance related to some bond strengths. But otherwise, I would say they're uniquely different.
Great. What would be another one of our mortars that has the same level of viscosity as the Keraflex line?
If you looked at viscosity, the only thing close to it would be the ultralight series. And as I said during the development of the ultralight, that was one of the unique properties of that product was the fact that it had a very smooth type of consistency. But we're talking about different technologies there. We're talking about a technology that's using 20% recycled content in the formulation. But that in similar comparison, that would be it.
Great. Well, We heard the timer. So that means that we have hit our hour. If there are any more questions, please, we're happy to always answer them. You can send them to mapeidigital@mapei.com, and we'll make sure that Brian gets them. And we thank you very much for joining us today. We know that you have busy schedules, so we appreciate the fact that you took some time to spend with us. Thank you, Brian, for a very awesome presentation. We'll put it up on our website shortly, and it'll be there for reference. And that concludes today's presentation. We'll see you guys next time. Thank you.
Thank you,
Have a
Jay,
good
and
rest of your day. Bye-bye.
everybody.